This is a web application that simulates robotics path planning using Google's Robotics-ER 1.5 model. It shows how an AI model plans movement paths for objects on a canvas. We have 1200 by 600 pixel canvas with light gray background and multiple draggable objects, multiple draggable shapes, circles, rectangles, triangles in different colors. You can drag objects to reposition them. You describe what you want in natural language, such as move the yellow circle to the left corner without touching any object. The app captures the canvas as an image, scales it down to 512 by 384 to reduce API costs, about 0.6 cents to 1.2 cents per request, and sends it to the Gemini Robotics-ER 1.5 model along with your prompt. The AI analyzes the scene and returns JSON trajectory. JSON trajectory is a series of waypoints, x and y coordinates, that form path for the object to follow. Uh, Then the canvas animates the object using that path using linear interpolation lerp for smooth and constant speed movement. The app demonstrates the same workflow used in real robotics. Perception. The canvas image represents what a robot camera sees. Planning. The AI generates safe movement path. Execution. The animation shows how a robot would follow that path. In real robotics, the same model would analyze camera feeds from robot vision systems, plan paths for robot arms to pick and place objects, generate trajectories that avoid collisions, control physical hardware to execute movements. So the app bridges the gap between natural language commands and robotic movement planning, making it easy to see that AI understands spatial relationships and generates safe, efficient paths for object manipulation. In our application, uh, JSON trajectory may look like this, where trajectory is an array of 2D waypoints in pixels x and y. Object ID is a description of an object to move. Duration, animation duration is seconds. Coordinates are relative to the canvas, 0, 0, which is the top left corner. But for a real robot arm, the JSON may look like this: X, Y, and Z, position in meters in 3D space, roll, pitch and yaw, orientation angles in radians, grasp pose where to grab the object, and units is measurement system. The canvas application uses simplified 2D format for visualization, while real robot needs 3D coordinates and sometimes joint angles or action sequences. You can make around 20 free requests to Robotics-ER 1.5 model on the free tier. To extend usage, I connected it to my billing system, which provides $300 of credit for 90 days. The application uses the Gemini API directly with your API key. Once you add the key to the environment file, you can start using the application. Let's test the application. I type move the yellow circle to the bottom right corner without touching any object. Here you see the trajectory path where we used linear interpolation for smooth movement. I can actually replay the animation. Now let's add obstacles to see if it will choose another path. Move the yellow circle to the bottom right corner without touching any object. I type move the green triangle through the gap between the blue circle and the purple rectangle to the top right corner. I type the red rectangle hits the orange triangle, then the green triangle, then the yellow circle, and stops. I type rotate the blue circle around around an orbit.